Hi, we're gonna present question 2 Aircraft Autopilot Control System. My name is Angela Wong.
My name is Li Jiaji.
My name is Zhang Jiayi.
My name is Sao Wei Liang. Let's enjoy this video.
Autopilot controls the trajectory of an aircraft without constant hands-on control. Data received from Global Positioning System (GPS) receiver installed on the aircraft. The receiver determine a plane's position, which can execute a flight plan. The aim of this project are listed as follow. First, to create stable aircraft autopilot control system. Second, to reduce steady-state error. Last one is to create reliable aircraft autopilot control system. To achieve the aims of this project, we had set the objectives as, to determine gain and phase margin of the system in Bode plot, and to design compensator so that the phase margin would be at least 40 degrees. To examine stability of the system, gain margin and phase margin are determined using Bode plot. From the block diagram, G of S is consisting from autopilot and aircraft dynamics, K, G of S is the resultant from both systems. Then S is converted to J omega. Since K equals 50, the following calculation is done. After finding proper form transfer function, it is then separated into 5 constituent parts. Then, for amplitude plot, each of the parts are drawn in Bode plot as following. For amplitude resultant plot, each of constituents part are added as shown in the table. Notice that there is a constant, log amplitude 20 log 17.857 equals 25 decibel added. This is resultant slope for a log amplitude plot. As for log phase plot, the following 5 phases are determined. Each of the parts are drawn as following. Its resultant plot is added from each constituent parts, shown by following table. Notice that there is a constant slope of -90 degree, due to the pole at S equals 0. 1 over J omega which has to be added. This is resultant slope for log phase plot. H represent the transfer function. GM represent the gain margin. PM represent the phase margin. Lag compensator is designed to make phase margin at least 40 degree. This would improves an undesirable response in the feedback. To find compensator, the following formula is used. Therefore, first, find alpha via crossover frequency. To find new crossover frequency, locate frequency where -180 degree added with 5 degree safety factor along with 40 degree phase margin. Its value is 2.57 radian where its attenuation is 13 decibel. First step is to find alpha by using attenuation found. Then, determine W, C, W, Z and W, P by using formula provided. Finally, determine tau using 1 over W, Z formula. To find W, P, we put 0 at 1 decade below the crossover and the pole 1 decade below 0. Finally, by substituting alpha and tau into this formula and then convert S into J, omega. Compensator is as following and G of S is as following. The new transfer function is the multiplication between both compensator and G of S. T, F refers to transfer function. D, C, F refers to gain crossover frequency. PM refers to phase margin.